Hi, my name is Mark Allman, and in this video I'll be showcasing my IFB102 mini project called COPAC. The Collaborative Online P5JS Art Canvas, or COPAC for short, is a project that makes use of web, networking, and language library technologies to create an application that allows users to collaboratively create art on a canvas made of pixels in real time. The project is hosted via a Node.js server that runs on a Raspberry Pi, which hosts the web page and the COPAC web application, which was developed using P5JS, a creative coding library for JavaScript. To set up the server, I first accessed the folder on my Raspberry Pi containing the project. Listing the contents, it can be seen that it contains a file called server.js, and when I run it using the node command, the server for the project begins to run. Once the server is up and running, I can then go to the COPAC website by typing in the IP address of the web server, followed by the port that the COPAC website is hosted on, which is port 3000. As you can see here, the COPAC web page is quite simple. The central focus here is the canvas composed of many squares or pixels. Below that are some instructions for how to use COPAC, and underneath that is a gallery showcasing some different versions of the canvas created over time. The main feature of COPAC is entering commands to color in pixels on the canvas. To do this, users can click on this input field, and here they can enter 5 numbers. The first 2 numbers are the x and y coordinates of the pixel that the users want to color in, which are then followed by 3 numbers which are the RGB values of the color they want to color in the pixel with. For example, I can type in 22, 0, 255, 0, and 0 to color in the pixel at the coordinates 22, 0, the color red. Users also have the option to save the current state of the canvas as an image by pressing the Save Canvas button. When they do this, this image is sent to the server as a base64 string, which the server then uses to edit the HTML of the web page in order to display this image in the gallery section of the web page. When I refresh the page and go to the gallery, you can see the latest image of the canvas contains the red pixel I added at coordinates 22, 0. The goal of this project was to have multiple users make changes to COPAC collaboratively in order to create a continuous real-time artwork. If I open another browser window here and go to the web page, you can see that the same canvas has been loaded, including the red pixel added before. This is possible because whenever changes are made to COPAC, they are saved to a database stored on the server, and whenever someone connects to the server, the data from this database is loaded into their instance of the web application. If I start typing in commands in this new browser window, we will see that changes made in that window appear in the other browser window. This is made possible via WebSockets, wherein the instances of the web application communicate with the server via WebSockets. Whenever a client executes a command, its information is sent to the server as a WebSocket message. When the server receives this message, it then broadcasts this message to other client computers connected to the web application, allowing for changes to COPAC to be shown in real time. Combined with the saving and loading of changes, this allows COPAC to be a real-time continuous artwork. Showcased here in this time-lapse, you can see that as commands are executed on one computer, the server then receives them and then starts to broadcast them out, which are then logged in the SSH client. Lastly, demonstrated here are multiple people on different devices connected to the COPAC web application, collaboratively making changes to the canvas in real time. Showcased here is a time-lapse recording of this session on an additional device. We can see that despite no commands being entered on this computer, the web server is receiving commands which are being logged in the SSH client, and pixels on the canvas are being colored in to create artworks, showcasing the real-time collaboration aspect of this project, which has been made possible by the communication between the server and client computers via WebSockets. As the users save images of the canvas, the resulting canvases are then written to and displayed on the web page, and so we can see how COPAC changes over time. That is all there is to the COPAC web application. Thank you for watching through this demonstration of how it works.